In this video, we're going to determine if a relation shown in graphical form represents a function. To do so, we'll use a visual test known as the vertical line test. So let's get started. We have a graph that's shown, and it looks a little bit like a parabola, but has it's more of a W shape. And we can see that both arrows are pointing up, and it's going through the point 0, 3, and then it comes down to 1, -2, and then bounces back up to 3, 2, and then comes down to 5, -2, and then heads back up. And so we need to determine if this represents a function. Now we know that in order to be a function, every input has to correspond to exactly one output. So we need to look visually and see if any of these inputs are associated with multiple outputs. So I'm going to grab a ruler. So I have my ruler, and I'm going to look and see, as I slide this ruler along, I'm going to look at the inputs. And I'm going to see if this ruler is going to pass through multiple outputs for a single input. So I'm sliding it from left to right. And I'm seeing that it's only crossing once. So what I'm seeing, I'm looking at every point as I slide this ruler that's on this graph. I'm seeing that each input here is indeed associated with exactly one output. And so what I'm using here is a visual test. I'll move the ruler out of the way now. What I'm using here is a visual test known as the vertical line test. The vertical line test can be summarized as follows. The vertical line test, to determine if a graph represents a function, says this: if any vertical line passes through a graph more than once, then the graph does not represent a function. And so what we're seeing there is that if the vertical line passed through the graph more than once, then we'd have found a single input associated with multiple outputs. So we would know that it is not a function. Second, if no vertical line passes through a graph more than once, then the graph does represent a function. And so as we were sliding our ruler along this graph, we saw, and I'll go back through it again, but we can see again that there's no vertical line that's going to pass through 2 points. So there's no input associated with multiple outputs. So we have verified then that this graph represents a function. So this graph does represent a function. And to summarize it, we could cite the vertical line test. We could also say each input is associated with exactly one output. Now let's look at the domain and range. So we're going to look at the inputs and the outputs that we have. And the domain is going to be the set of all possible inputs, and the range is going to be the set of all possible outputs. Now we can see that this graph is continuous, and we can see that there's 2 arrows pointing upward. So looking at the domain, I'm looking for all possible x values. So I'm going to come along the x-axis and look, and I can see this arrow, and so I'm going to just highlight along this x-axis. And I'm highlighting along there, and I can see that that arrow means it's going to continue indefinitely on the right. And the arrow also means it's going to continue indefinitely on the left. So my domain for this particular function is all real numbers. So I can write that as an interval from -infinity to infinity. Looking at the range, if I look at all possible y values, I can see that there are 2 arrows at the top pointing upward, so there won't be a maximum value. But as I look along that y-axis, I'm going to highlight along this axis for all the places that I see y values, and then I stop when I get to -2. So I'm going to have all values for y, -2 and greater. So when I write that as an interval, I can write -2, infinity. Another thing that I can do along this, outside of this grid, I'll come over to the left here, I can see, I'm going to write something similar to the interval, that from -2 upward, those are all possible y values.